Hey, what's going on, guys? Let's see how we can calculate this work done on the system. You see that this is initial state and this is compressed after this, right? So it means work done on the system. So the answer should be negative. If it's work done on the system, answer is negative. If the work done by the system, answer should be positive. So here, let's see how we can calculate. First of all, they are saying it's an adiabatic process. So whenever we have adiabatic process, the Q is always 0. Heat is 0. So heat transfer is 0. So Q is 0. Therefore, we know that delta U is equal to Q minus W, right? So if Q is 0, this is first law of thermodynamics. If Q is 0, delta U is going to be equal to minus W, right? So whenever we have in this kind of situation, delta U we know that we can find it using NCV delta T, right? So let's apply that one and see whether we can find it. So here we are trying to find the work. So work is going to be negative delta U, right? Negative delta U. So negative delta U mean this is going to be negative NCV delta T. And also the mole is also provided in the question. We need the mole, right? So mole is 0.0208 mole. So this is the mole, and they are saying this is a diatomic gas. So we need these two information in order to do this question. And let's see how we can do this. So first of all, we have mole right now. So let's expand. Let's see whether we have everything. For N, we know that already. For diatomic gas, Cv is going to be 5/2, right? For monoatomic, 3/2 R. For diatomic, it's 5/2 R. And delta T, we have to know the initial temperature and final temperature. But we have initial temperature, we don't have the final temperature. So we have to find that one. So to find the final temperature, we can use this equation. That is T1 V1 alpha minus 1 is equal to T2 V2 alpha minus 2. Alpha is basically the ratio between Cp and Cv. So for a diatomic gas, Cp is going to be 7/2R, right? And Cv is equal to 5/2R. And then from this one, the 2 cancels. We get 7/5, and R also cancels. That gives us 1.4. So the gamma value is 1.4. Do we know the initial volume? We know the initial volume. We know the final volume. And then we know that we know the T1. So we can calculate the T2 using this information. T2 is going to be equal to T1 times V1 over V2, V1 over V2 gamma, this is minus 1, gamma minus 1, and then this is T1. We are trying to find T2. So T1 is 293 Kelvin and V1 over V2. So here they have given V2 is equal to 1/15 V1. So if I put V1 right here, and this is 1/15 V1, V1 cancel, the 15 goes to the top. So we will get, this is going to be 1.4 minus 1. So we will get 293 times 15 power 0.4, right? So this is what we are going to get. And if you calculate that value, that's going to give you 865.6 Kelvin. Now we have the final temperature. Now we can go ahead and plug in this equation and find the work done by this one, work done to the system. So from this one, let's calculate everything. So let's plug the values. We have this mole that is provided 0.0208 mole multiplied by Cv. Cv is going to be for a diatomic gas 5/2R. 5/2 R is going to be 8.31 joule per mole Kelvin times delta T is going to be T2 minus T1. So that's going to be 865.6 minus initial temperature was 293 Kelvin, right? And if you plug all these values in calculator, you will get negative 247 Joule. And that's going to be the answer for this question. I hope you guys find this video helpful. See you next time.